This video presents a simple calculation of neutrino mass by comparing neutrinos to molecules. The calculated neutrino mass agrees closely with the measured neutrino mass. It provides a strong hint that electromagnetic waves and light are propagate through the medium of neutrinos. In kinetic theory, the equation shown here is a well-established relationship between two different types of molecules. In this equation, m represents the mass, c denotes the wave propagation speed, and gamma is the heat capacity ratio. For calculating the neutrino mass, let particle 1 be nitrogen, N2, and particle 2 be the neutrino, nu. By substituting all the known values into the equation, we can use this equation to calculate the neutrino mass. We know that the mass of nitrogen is 4.65 times 10 power to minus 26 kilograms. We know that sound waves propagate in nitrogen at a speed of 349 meters per second. We also know that electromagnetic waves travel at the speed of light, 3 times 10 power to 8 meters per second. We know that the heat capacity ratio of nitrogen is around 7/5. We don't have an empirical heat capacity ratio for neutrinos, but the entire possible range of the heat capacity ratio is between 1 and 5/3. By substituting all known values into the equation, the neutrino mass is between 0.025 and 0.042 eV/c². You might ask why the entire possible range of the heat capacity ratio is between 1 and 5/3. Maxwell's mechanical formula for the heat capacity ratio uses two equations to relate the ratio to the translational kinetic energy and rotational kinetic energy. When the rotational kinetic energy is infinite, alpha is infinite, and the heat capacity ratio, gamma, is 1. When the rotational kinetic energy is 0, alpha is 1, and the heat capacity ratio, gamma, is 5/3. The calculated neutrino mass ranges between 0.025 and 0.042. The measured upper limit for the sum of the three neutrino masses is 0.12, based on CMB, SDSS, and BOSS measurements. Dividing the sum of the three masses by 3 gives an upper limit for the average neutrino mass of 0.04. The calculated mass aligns closely with the measured value. The single equation used for the calculation can be obtained by combining two well-known equations. Equation 1 is the Maxwell distribution of mixed particles, and equation 2 is the relationship between wave speed and collision speed. In summary, the calculated neutrino mass agrees closely with the measured neutrino mass by comparing neutrinos to nitrogen. If this agreement is not a coincidence, it is a reasonable argument that, similar to how sound waves propagate through the medium of air, electromagnetic waves and light propagate through the medium of neutrinos. Thank you for watching.